So now, let's take a non-linear equation and see how we can predict what the slope is. F of x equals x squared plus 1. This is a parabola. I don't know if you remember that or not, but the vertex of this parabola is 0, 1. And it's an upward parabola. So we look at various points throughout here. In this particular problem, they ask us to look at the point 2, 1. Oh, wrong one. That's not right. At 0, 1. So that's the vertex. Well, if we know that's the vertex, we can pretty much know what that's going to be, right? If you can imagine a parabola with a tangent right on the vertex. Now remember, the parabola is coming down, coming across, going back up. So it's slope down, slope up, and what happens when you go from slope down to slope up at that, what we call inflection point? What is the slope going to be? A horizontal line, meaning it should be 0. So we know what this is going to be, but we're going to do it anyway, and then we'll do another point on this graph to show how it changes when you go to another direction. Okay? So let me put the definition of slope down there again. M equals f of c plus delta x minus function of c over delta x. And we're using the limit as x approaches 0. Because we want that distance to be basically non-existent. But slightly more than non-existent. It's going to be just, you can't even see between those 2 points. And that'll give you the absolute slope value for that. So, this is your function. So we're going to replace c plus delta x right there. And so that's going to give us then c plus delta x quantity squared plus 1. So that is our y2 minus y1, where the c gets put right in here. And so this becomes c squared plus 1 over the change in x, which by definition is delta x. Minuscule delta x. Oh, we got some algebra to do here. Yippee-yi-yo, here we go. We're going to square it. Now, for those of you, and I don't know exactly how complicated the problems are, but there is a process called Pascal's triangle that will help you to predict what the coefficients are for when you get squares and cubes and fourth powers and all that. If you have anybody in the class from Scholastic, they'll be more than happy to show you that, because it sure makes life easier if you figure that out, rather than multiply all that garbage out. But this one right here, well, I'll give you the first 4 parts. We have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Now, this tells you, the fact that we have a 2 right here, that tells us that this is going to be the role that we're going to use for that. Now, this isn't the only way to do it, but this is a fairly quick way that we can figure this out. So that means that we know that there's going to be a c squared term first. There's going to be a c delta x term next. And there's going to be a delta x squared term next. Because when you multiply out a binomial, the exponent goes from highest to lowest of the first point, and from lowest to highest to the last point. So in other words, we start off with a c squared and no delta x's. So the c squared goes down to c, and then the delta x appears first over here. and then delta x is going to be squared, and then you go c. So it goes 2, 1, 0 for c, and 0, 1, 2 for the delta x as far as exponents are concerned. All that minus, and then it's just that, c squared minus plus 1, but the negative sign changes the signs for both. So it's negative c squared minus 1. All over delta x. And remember, we're dealing with the limit of x as delta x, not x, maroon, delta x approaches 0. So now we combine terms here. We got a c squared here, a c squared, negative c squared there. They cancel out. Okay? And it looks like I forgot the plus 1 here. I should have put the plus 1 there. I stopped and just did all this, but I forgot about this plus 1. So that's got to go there. And that's going to cancel out the negative 1 right here, so that will be gone now. And there's another case, and because I'm thinking of 10 different things at once, trying to prepare for the next point and all that, I forget the details. And it's really easy to forget details. So there's a good example of it right there, what I just did. So this becomes c delta x plus delta x squared over delta x. Now I'm going to factor out the delta x out of both of these. Delta x times, that leaves me c here. C here. C. Okay. And then we take the delta x out of delta x squared, and we get delta x left over, and that's all over delta x. And of course, now we can cancel out. We couldn't before without it being shown that it's factored out of there. That cancels out there, that cancels out there. That leaves me c plus delta x. But there's always that big but. The limit of delta x, upside down delta, come back, delta x approaches 0. So as it gets infinitesimally small to the point where there's no space between it, that delta x drops out, and our answer is c. Well, the question is, what is c? Well, c is the original value of x in this problem, and this is our c right there. So we plug in 0 for c, we get 0, and just as we should have predicted, this is a horizontal line at that point. The tangent is a horizontal line. So it proves to be correct. Calculus is phenomenal, how things just work out. But your skills in mathematics have got to be sharpened. And I know some of you are afraid of that, but don't be. You are on the verge of becoming really good math students. It's just too bad that the SATs, when you give it before you get that chance to really blossom as mathematicians, because everybody in this class should have a good score of at least 600 on the SAT for math. But I don't know how that's going to work out, but you will get better as time goes on. Okay, so now let's stick with the same thing. F of x is equal to x squared plus 1 again. But now we're going to pick another point, and that point is negative 1, 2. So the question is, what is the slope of the tangent? In other words, the one line that will intersect this curve at that point, what is its slope going to be? So we do exactly the same thing we did before. Okay? And when we do that, we again end up with C. So we go through the whole process, exact same thing, And now we end up with C as our answer. Well, C is the value of x at that point. So the value of C is -1. And that is our slope. Now, that is just a coincidence that we end up with C. That's rare that happens. But this is what occurs here. You end up with whatever you get, and you plug in this value for C. Sometimes if you have like 3C, well, in that case it would be -3 would be the slope. Or you might have a -4C, which the slope they would be +4 for that particular point. So it just depends upon the formula of the curve that we're dealing with. Okay? All right, so we've got tangents of curves, we got tangents of straight lines, which are really easy. And the thing we got to remember though is that we have one little problem with this. And that is a curve that's going to look something like this. And God help me as I try to draw a curve that looks like it belongs there. That's not too bad. I'm kind of proud of that one. All right, so you got this curve right here, right? And I'm going to pick a point, let's say right here. And I want to find the slope of the tangent at that point. Okay? So, here's the thing. You'll notice, and I'm just going to draw a bunch of goofy straight lines at various points, estimating about what the tangent should look like. And I'm going to make a supposition here that is a factual one, and you'll see what I mean when I get to it. All right? So, if I draw tangents here, follow the change of the slope as I do this, you notice that the tangents keep getting steeper and steeper and steeper to the point where we come to this point right here, and then we're going to go past it, or we'll come back to that just a little bit, and you notice that the tangents, which I'm drawing an absolutely awful job of, are starting to decrease. It's really high, and then it's starting to decrease. So this is actually a story of two curves, split in half. This curve coming here, and if it were to continue on, it would actually do something like this. So that means then that you have a tangent going that is going to hit the curve at one place. If I draw a tangent like that right here, it's going to hit this curve right here. But because this curve is behaving like two different curves, then if I look at this one right here, this is coming around like this, and that's going to come around like so. So there are two hyperbolae going in two opposite directions. So what's going on here is I've got a vertical line that is going to be tangent to both of those curves. Well, what's the slope of a vertical line?